Hello, everyone. Welcome to another episode of the Day Zero podcast. I'm Spectre. With me, as always, is Z. Today's show has quite a few cool topics, including some kernel exploits, Rust in the kernel, fast fuzzing with coverage guidance, and taking over GitHub repos through malicious pull requests. So we'll start off with Rust. We'll keep Ferris happy. So Rust files have been added into the Linux kernel, which seem to be intended for kernel modules to use. So this was one thing that is important to note. It's not like the kernel core is being rewritten in Rust or something. I don't know if that's ever going to happen. But you got to remember that Linux kernel is like two main things. It's the kernel core and it's the driver stack, or the Linux kernel modules. And the kernel modules are like the weak link in the chain of where if there's a vulnerability, it's probably going to be in a driver. So adding Rust to the driver stack makes a lot of sense from a developer standpoint, because the memory safety can be useful there. Now, sometimes you might have to do something that requires, unsafe memory accesses, like if you're doing DMA or something, but not all drivers are doing such low-level operations. So, yeah, I mean, this kind of spread throughout the communities I'm in. A lot of debate on whether or not it's a good or a bad thing, because Rust is pretty divisive among our community, I would say. What do you think, Z? Good or bad?
Well, ultimately, I think it's a positive move. I mean, in these days, C is, or I've said it before. I mean, you can write safe C and you can do it successfully, but that's mostly an in theory thing. In practice, nobody manages to write completely bug-free C code. So, being able to eliminate entire classes of bugs using another language is a fair option. Now, there are concerns with using Rust when it comes to I think you've raised it before, the compile time aspect of it, where just the development time, that development cycle, if it takes 20 minutes to build instead of 10 minutes, that's kind of a big deal. So there are those concerns with Rust. I think ultimately it is a net positive to see Rust, or to see just a safer language and the option to use the safer language kind of being presented here. As you already mentioned, they're not looking to rewrite all 20 million lines of the kernel in Rust, but they do want Rust to be an option for new code. And you've got really, I think the big benefit really just has to do with this whole slices and all of that, where you've got the length integrated, or it's known at compile time. Well, not necessarily known at compile time, but it's able to enforce the checks where they need to be without the developer needing to remember every single place to implement it. It's the same deal when I talk about just having centralized security. You're getting that when you use these sorts of languages. Rust is kind of designed to be a systems language. It makes sense. It does a lot of C sort of things that it uses, or it's kind of like a better C in the way that the kernel likes C to be. So there's no garbage collection. Your errors are with return still. OO is still kind of using that op structure, which is kind of a pattern you see within the kernel. It makes sense. It's not like some huge shift away from the C paradigm. So I think it's a net positive. It's yet to be seen exactly how some of the softer impacts will apply, as in the compile time stuff. That said, I mean, one of the major bottlenecks, so back when this was being discussed, I think it was back in August on the mailing list, they were talking a little bit about this in prep for a micro conference, part of, I think, the LLVM micro conference at the Plumbers Con. They were talking a little bit about what needed to happen to see Rust in the tree. And performance wise, compile time on a 3-minute build, adding Rust in took closer to 4 minutes. So that's a substantial increase in time. But on the iterative compile, so when you're talking about just compiling a Rust module, not the entirety of all the Rust shared code, the compile times are very similar. So I don't know if that's going to scale as it's used in more places, but it is kind of a positive note, at least.
So, I mean, this is going to help with a lot of vulnerabilities that are a lot of vulnerabilities that end up coming out of the kernel that I've seen are not when it's doing anything super complex where it absolutely needs to, like in DMA routines or something, right? It's going to be in something trivial, something stupid, like getting user data into a buffer or parsing user data that's already in a buffer. And Rust is going to help kill those kinds of issues. The other kind of issue, well, so
I think the other
I
thing is
have
you're
seen some
tagging
concerns
memory.
raised. Yeah, you're tagging memory.
Yeah, like the
Um,
safe and unsafe, I guess I say. Not like memory tagging, but like that's another thing. Like it makes the auditing easier.
yeah, you have those red zones to kind of look for of, uh, there could be danger here.
Yeah.
Um, Now, I mean, I have seen like a little bit of discussion around like what could get broken by using Rust, or like wondering how things will work. Like RCU was one thing that was kind of like, I'm not totally sure how that'd work. Now, RCU in and of itself is like really uh,
So interestingly, that actually
unintuitive.
RCU itself actually came up during the plumbers talk. I'll add the link here. So unfortunately, with kind of the Linux plumbers conference, the video itself is just the LLVM micro conference within it, and then it's about 35 minutes into there that the barriers to entry Rust comes in. During that talk, he does talk a little bit actually about his the RCU binding that he was actively working on at this point. Uh, so like RCU itself does come up here as something that they're talking about, but a big thing is they want to make sure that basically everything that's being written in C in the kernel can be used from Rust and vice versa, which is actually kind of one of the benefits that they get, and some that's discussed here is over, cross compiler stuff. So when you have like part of the kernel being compiled with GCC and part obviously with Rust, you've got to be using an LLVM. So when the entire thing's in Rust, or sorry, when the entire thing's being compiled with an LLVM compiler, so you've got the C part, like they're both compiling to like the backend LLVM, which kind of gives the benefit of cross-language optimization. So, things being written as inline in C can be inlined into Rust also, and various things like that. Like there's a lot of possible interoperabilities there. And he ends up talking a lot about like the goal or the plan, or at least some thoughts there for, dealing with structs, dealing with the ABI and all of that too. That it's a decent talk about it. I mean, it's mostly talking about the berries and just thoughts about it. It's not really solidified exactly what Rust is going to look like in the kernel, but seeing this commit is starting to see like now they're making a real attempt. And I guess should also mention this is in Linux Next. It's not in the mainline kernel yet.
Yeah, Linux Next is like the active development branch for those who aren't familiar with that terminology.
Kind of. I mean, a lot of active development still happens in their own branches too for specific features, and then before a patch lands in mainline, it lands in Linux Next.
Yeah. So yeah, like you were saying, like the level of native interoperability looks pretty good. Um, Now that said, like not only is this like just in Linux Next right now, but even when this does land in the main kernel, I don't think it'll be super quick that you'll see a lot of drivers converting to Rust. I think it's going to take quite a bit of time. It might even be like a year or more before you actually see a significant amount of drivers being converted to Rust, because how like Linux kernel development is a little bit interesting, right? Basically, a lot of, especially the driver stack, it's all going to have its own like subsection of maintainers and developers that are responsible for it. So it's going to be kind of up to them to, switch their driver over to Rust. And some drivers might not even like be able to easily do it. Like I said, like if you're doing some of the DMA stuff, I could see it being a problem. Um, but yeah, I mean, it's something to look out for, and it is showing that there is some sort of incentive to get memory safety into the Linux kernel, in a more aggressive manner. I do find it interesting that Linus was like okay with this. Apparently, somebody did say that Linus has expressed his, you know, good graces, I guess, for Rust before. But it is one of those things where, like, when it comes to the kernel, Linus is really, really touchy about introducing things when it's purely for the benefit of security. He's always had kind of a negative outlook when it comes to security researchers, and such. So when it comes to bringing memory safety into the kernel at the potential expense of maybe a bit of runtime performance and some compile time performance, that seems like the kind of thing that he might object to, but it seems in this instance that that's not the case.
Yeah, and I haven't found a message where Linus is specifically commenting on Rust, but he does comment a couple times in the mailing thread about this presentation. He does comment a couple times, and neither time is he actually like taking a negative stance like against the idea of introducing Rust. He has some comments about actually doing it so like if you're adding it, like you're not adding it in a hidden way, like it needs to be based not exactly on by default, but like it shouldn't be something that's hidden away so that only those who want it are getting it, and it's not getting tested in general. So like kind of a tacit approval of it, I guess.
Yeah, I guess he doesn't want it buried in some obscure kernel option. So I mean that's fair. Um, but yeah, I mean, just something that's worth keeping a lookout for. Now, obviously, Rust doesn't like we've made this meme before, but Rust doesn't automatically mean it's perfectly secure or something.
I
These
mean,
drivers are going to have to use those unsafe zones, like we mentioned, but there's also other bugs that aren't purely memory safety. There could be like a missing privilege check or something like that. That's another fairly common bug that Rust wouldn't help against.
well, and
So
we've talked about before, like bugs that can be introduced just in misusing things across the unsafe and safe boundary.
yeah,
Like we did a talk about a paper that was covering a bunch of issues that you can still have, like memory corruption issues that can be introduced in Rust. Like it's all still there. It's just the safer language naturally has some benefits or some security benefits.
yeah. Overall, I think it is a good step, though, and I kind of agree with you. I think it is a net positive, even though personally, I'm not a huge fan of writing Rust. I've tried to get into it a few times, and I find the syntax super annoying. But it is hard to deny some of its benefits when it comes to security. So yeah,
Yeah, and I'd
overall good
say
move, I think.
it's also just something to pay attention to at this point or at this stage. Is there going to be a huge performance hit? Like that might change my opinion on this if suddenly there is a huge performance hit, or if there is a huge compile time hit, especially on the iterative builds, not just on the first build. Although first build is still a thing, and even just on the resources needed to do the build, if adding Rust, suddenly it takes like an extra 10 gigabytes of memory or something, that'll kind of suck. On a
Yeah,
whole,
I'm
though,
actually curious what the memory impact would be on that. I'm not sure how memory intensive like compiling Rust code is, especially when you're talking about on the scale of like the Linux kernel or the driver stack. So that would be interesting to take a look at. Yeah.
yeah, and once we start seeing more code in Rust or more modules using Rust, we might start being able to see how that's working out, I guess. But at this stage, I'm kind of hopeful. We'll see how that goes.
All right. So we'll move on to another thing that's been circulating around on social media. Some of you have probably already seen this. So two undocumented instructions to update the microcode was discovered on Intel CPUs. This had a very strong vibe of like the Christopher Domus talks a few years ago at Black Hat and DEF CON, I think 2019, where he talked about, actually might have been 2018, where he was
Yeah,
talking about using
2018 Sensifter.
yeah, so using Sandsifter to try to basically fuzz for undocumented instructions by doing like timing attacks and stuff. Really cool research. So yeah, there were these two undocumented instructions found for updating microcode. This has been circulating around a lot. A lot of people in the tweet chain seeming to think it's the end of the world and that like all Intel CPUs or everything running as Intel CPU is now completely compromised or something. Um, and I think something that a lot of them are leaving out is the fact that it's not like this can just be hit on any system. It does require a specific configuration when it comes to ME, right?
Yeah, well, specifically, it requires that it's in what's called the red unlock mode. That is a service mode. You all like if you're in red unlock mode, you already have access to like the MS ROM where the microcode actually is stored. I mean, it's signed. You can't just go and modify it, but you already have access to that. Even at that point, like it's not a your consumer CPU isn't going to be running in that mode by default. That's something like as a researcher, you exploit Intel like the management engine, the Intel ME. Exploit that, and then you can get into that red unlock mode, but it's not something that you're just easily accessing. There are a few comments saying that JTAG was needed. That's not the case, and the guys who found this have confirmed that you don't need JTAG. So it's not you don't need hardware access. It is something you can like still get to with software, but it's not like just any random binary on your system's going to be able to say, okay, run these instructions to update the microcode. It's more complicated than that. So the security risk, and actually even at that point, I don't know how much like modifying microcode, like what's your attack there? Microcode, if you're not familiar with microcode, it's basically the instructions that actually implement the instructions that you use on the CPU. So like move and all of that will have microcode instructions behind them. Like from a security point of view, I'm not even too sure what your attack would be if you're just able to modify something microcode. Now, don't get me wrong, I'm certain somebody can come up with an attack for it. I don't know if anybody's really looked at launching attacks from modified microcode, like backdooring microcode in some way. Like, I actually feel like that might be an interesting area for research.
Honestly, it's just one of those areas though where there's just far easier attack vectors if you're going for like where you would use this kind of attack, you can use other attacks for like far less resources expensed. Um,
I mean, you're already running code in a very privileged context to get here.
Exactly. Yeah, when it came to the tweet, it's kind of funny. Like the first tweet we have on screen here is what a lot of people took and ran away with. But the tweet, like just underneath it, was where he talked about the red on lock state, and it would throw the UD exception if you weren't in red on lock state. So people saw that first tweet and ran away with it and didn't even read the second one. Classic social media, I suppose. But yeah, I mean, this is mostly just like a debugging like trapdoor that it's not even like the trapdoor was left exposed. It was just it's just there. I guess you could argue that maybe on like CPUs are shipping into production, they should strip those instructions out. But like again, it's kind of a non-issue, really. It's an interesting finding. I don't want to knock the finding.
Well, I don't even know about stripping the instructions. Like, it might have a use in the service sense. Like, I don't know. I've never sent in like a CPU under warranty or something, but I could imagine something like that.
Yeah, that's a valid point. So yeah, I think a lot of people were making like thinking there was a fire because of like a little bit of smoke, and really like it's just an interesting finding. It's not some massive attack it's not like the new meltdown inspector attacks or something, which is what it seemed like a lot of people thought this might be. So yeah, I mean, not a ton to talk about around this issue, but we did want to bring it up because it did seem like there was a lot of FUD going around, at least on like some of the social media circles. So all right, we'll move into our exploits section. So our first few are in the DuckDuckGo Privacy Essentials browser extension. The blog post details 2 issues, which have been resolved for a while on Chrome, and more recently on Firefox and Edge. Weirdly, the fix update was skipped initially for Firefox and Edge, which is strange, but anyway. First bug is yet another abuse of post message, and is mainly centered around how the content script uses messages that aren't private. They use post message to coordinate actions between iframes in a window, and when an iframe gets loaded, it'll send a request to the parent frame where the content script would use post message to send the frame ID and the main frame's URL to it. The problem is, while that's mainly intended for the content script, it can also be read by the web page. And it can be used to leak the full address of the parent frame as well as the ID of the frame that's loaded. And these are things that an iframe isn't supposed to be able to know. It's supposed to be kind of isolated from that information.
Yeah, I mean,
So
the idea here is that the DuckDuckGo extension adds in its content script, and then on every iframe that it's kind of inject there, that includes this class name DDG hidden. It's just sending that frame URL. Like Spectre said, it's not something they're supposed to see, but because they are just using the post message and sending it along, any website could, in theory, hook these messages. Because the post message effectively just comes through as an event that you can hook just like any other event in the browser.
yeah, there's like no like security on it at all or anything, or
Yeah, like
there's no guarantee that it's private.
you can do some like origin checking when it comes to where it's being sent from. There are a few things that can be done, but the way that this extension's working, like it's meant to work everywhere, so they can't really limit it in that way.
Yeah. There was another problem related to using messages on a public channel for hiding blocked frames. Basically, anybody can send messages to hide elements on the page, and it doesn't do any checking to ensure the element you're hiding is an iframe, because that's what it's intended to do, right? Is block or hide blocked iframes. But because they don't even check that it's an iframe, you can actually use like send a message to hide any element in the document. So they mentioned that could be useful for something like clickjacking. Um, the second main bug they detail, though, is the usage of the tabs.execute script API, which is used. You can basically, it's kind of like the uh, exec of JavaScript. You can use it to pass JavaScript code as a string and get it executed on the tab ID. The script they pass in they build it up by using a user agent string and put it into a variable, but it does so with no sanitization. Um, so you can kind of break out of that and inject your own information or your own code into that script. Um, so so it is a little bit. Uh, are some specific circumstances around exploiting it, because where that user agent data comes from for spoofing isn't easily controlled by an attacker. It's downloaded from a static content delivery network from DuckDuckGo. They still wanted to call it out, though, because if anyone can compromise that server, either from the inside or externally, they can now get a Universal XSS that can not only execute arbitrary JavaScript, but it can also send messages to the extension's background page as well, which can allow an attacker to change settings and do other things as well. So, yeah, both issues were resolved. The first set of issues were resolved by removing the content script entirely. The XSS was fixed by sanitizing the user agent string by using JSON stringify,
Yeah,
which is fine for that case.
I do kind of want to mention here, like getting the agent, it gets the agent using where was it downloading from? It was downloading from the CDN. I want to say it was DuckDuckGo, one of their CDNs. Yeah, staticcdn.duckduckgo.com is where it would get that user agent from, because this is part of the spoofing aspect of the extension. It would spoof your user agent by just giving it an agent out of, I don't know if it's a list or if they'd always use the same. I imagine it's a list, and it would, when you called get agent, it would choose one at random. Just kind of make fingerprinting harder. Either way, it is downloading it from a trusted location. So in order to actually exploit this issue, like the Universal XSS, somebody would have to compromise like the DuckDuckGo CDN. It's not like just any website would be able to compromise this. So like that is a pretty high ask. Definitely a possibility it's reading it, but it's not an easy ask, especially, you know, replacing a user agent with a XSS payload. You might get a ton of hits. I feel like it would be seen pretty quickly if this is used like anywhere else. That
Yeah,
said,
it'd be pretty noisy.
it does have that high ask, so I wanted to point that out. It's not just like a really easy Universal XSS. You need to compromise DuckDuckGo, which this attacker was not able to demonstrate the ability to do. They just know like this code is trusting it from a third-party resource that could be compromised in theory. And I mean, the solution there was just using like JSON.stringify, like injecting in a more safe way. So it's not like it was a hard fix.
Yeah, they did quickly mention with JSON stringify, like that's not always going to be the best solution for trying to prevent XSS because it could allow like closing script tags, for example. But in this case, that's not like an issue because of the way it's used. But they did call that out so that people are aware of that are reading it. Mainly, though, what this article calls out is it's calling out browsers for not providing convenient and secure APIs because especially the first set of issues they only really exist because extension devs commonly use the post message API for internal communication because the secure alternative, being runtime send message, is far less convenient to use. So they're trying to do like a, I guess, petition for browsers to add a more convenient API to use that isn't as easy to get misused as post messages. Um, Similarly, they argue that the tabs.execute script function is a sink that should just be removed altogether because it only basically has one specific use case that they outline, which is pass through configuration data, which in that case, they should just extend the API to have a function that does that specifically instead of providing this kind of dangerous function where you can just pass a string in and get it executed. So, yeah, that was the two main callouts of the article. I think I would agree. When you see, especially with the post message thing, when you see so many extension developers using that, that's kind of a sign that like there's an issue at the API level that should be addressed, I think. So, yeah, I mean, we'll see if like, Google and Mozilla and Microsoft address that in the future. I don't know if they will, but um, I do kind of agree with that sentiment. So. All right. Up next, we have a binary-based post around VoIPmonitor. It's fun because it's not only about a bug and how they exploited it, but it also includes some information about how they found the bug, talking about how they leveraged SIPVicious Pro's fuzzing tool to send malformed SIP packets and find a crash, which they did. They found a crash due to a stack cookie getting smashed when sniffing packets from the network interface, specifically when it came to saving them into a SQL database. The bug was really straightforward. It was a stack overflow and constructing a description in a 1024 byte buffer on the stack. Now, on their build, this would have been very difficult or impossible to exploit with all the mitigations. They got a stack cookie in place, which actually triggered the crash in the first place, which on its own probably would have killed this bug. But what they discovered was, for some weird reason, the static builds that are downloadable from VoIPmonitor, they don't have security features turned on. Um, so they were able to take this to code execution on those static builds. The exploit was pretty standard stuff. They smashed the return pointer of the function and do a ret to libc attack. It was like you time traveled back to like the 2000 type exploits that are in a lot of the beginner exploit courses. Um, in terms of timeline, the issue was fixed pretty quickly. It was reported on February 10th and fixed on the 15th.
I
But
will give them kind of a little benefit here. It ultimately did ret to libc, but they did use a separate gadget in there to modify the, I think it was RDI, so that RDI would point to where they wanted just before they actually did the return in the system. So technically, I mean, there was the extra one gadget there to increment RDI before it, so it was more traditional ROPy, I guess, but not by much.
yeah, this is like a mini ROP chain. Um, yeah, I mean, overall, this seems to be a pretty soft target. When I was looking around a little bit, like I did do a little bit of looking into the code that they were referencing. Code quality does not look great, honestly. Static builds, again, for whatever reason, they don't have any exploit mitigations. I'm guessing that's still the case since it wasn't explicitly called out in the article's fix section that was addressed. Um, I really don't like. We kind of talked about it, I think, on last episode, but uh, I don't understand why people aren't enabling, like, are disabling exploit mitigations in 2021. Like, the performance
Performance.
impact is so minimal that it's, especially like stack cookies.
But
Like,
it's there. I mean, if you see it, you can say like um, or you have it on there and then you fix the performance issue, like you improve the performance by removing it, and you pass that up to your manager or something. I don't know. I mean, to some extent, I don't know how many devs actually understand what like DEP and ASLR necessarily are. I'm not trying to say like no dev understands this thing, but at the same time, there is that slight barrier to actually understanding how much security those things offer. Or a fortified source. Like, I could understand why some devs just don't recognize the value in them.
Yeah, it's just like it's something where at this point I feel like I just don't really understand how it can be explicitly disabled.
Yeah, I
And
mean,
there are people that make the performance argument, but it's like your bottleneck is probably somewhere else. Your bottleneck is probably not these mitigations that are being put in. But yeah,
I
I mean
would.
that's a fair point about them potentially not being aware of it or not
Well,
aware of its
the
importance.
thing is, like, they had to turn it off. They're turning off things by default. Somebody was aware of it at some point. Was like, nope, we don't need this.
Yeah.
Kind of on the other side, though, this is a network tool, and I would definitely argue with any sort of network tool, more mitigation should be on, not less. If it has that network access, if it's going out on the network, that's just immediately a huge attack surface, and thus should have ASLR. I think it's a lot less kind of egregious of an issue when it's, oh, you've turned it off, but like this is a user land program running as, the user that started it. Like there's no LP potential, there's no networking potential. Like that kind of lowers the attack surface.
Yeah, I agree. Like things on the network should be running more mitigations, not less. Thank you, Smash 8 Tap, for the raid. Welcome in, everybody. Um, so yeah, I mean, I think this is a soft target. It might be a good target to look at if you're looking for like something to do. You're looking for like quick fun or to get issues under your belt. This might be something to look at because it looks like uh, if somebody was determined enough and wanted to look, like there's probably a lot of other silly issues in here too that you could probably take to code execution due to the lack of mitigations. So yeah, could be like a real world CTF basically. So another episode, another GitHub vulnerability. Teddy Katz wrote a blog post about a bug they ended up discovering through trying odd stuff in regards to pull requests. So when you submit pull requests, you have control over a few things, right? Obviously, you have control over the contents inside of the pull request of what you're changing. You have control of the name and comment on GitHub. But importantly for this bug, you also have control of the base branch. And you can set that to any string. So they thought, okay, what if we set it to something that's not actually a branch, but it's some other identifier that's used somewhere else for in Git, like a commit hash, for example. They discovered that didn't work immediately, but what they also discovered through another issue was the fact that GitHub had stricter input validation when it came to creating pull requests than it did for updating them. So, like when they tried creating a pull request with a reasonable branch name, then updating it later to include or to change the base name to the commit hash, they managed to create a pull request with a commit as the base branch. Um, Now, part of why that's useful is because on GitHub, commits are shared between forks, meaning a commit hash from a fork can be referenced in the main repository, for example. So, creating that confusion didn't gain you anything right away, but by throwing GitHub Actions into the mix, which for those who don't know, GitHub Actions is basically used for continuous integration. You can set up hooks to like automatically build your project upon pushes and stuff like that. So yeah, when you throw that very useful feature into the mix, um, you can create a malicious workflow that'll do something like steal an access token on the pull request target event and then commit it in a fork. Then, by updating the pull request main branch to the commit hash of your malicious action workflow, it would immediately run that workflow due to the trigger you set up. And then, like, the token for the repo could be exposed, which could lead to compromise of the repo and any other services that were integrated with it. So, this was a relatively trivial bug in terms of how it worked. It was just a confusion with identifiers and the pull request base name and commit hashes, but it had catastrophic potential impact. Like they mentioned, this could have been used for a widespread supply chain attack because a lot of projects directly publish to package managers from GitHub. So if somebody compromised a repository using this attack, they could pull off supply chain attacks Similar in impact to like when we covered the Node.js or the package manager attacks that could have led to the potential compromise of like Facebook and Netflix and all the big companies a couple episodes ago. For timeline, the bug was reported on February 4th. The fix was shipped the same day, which was basically to prevent setting the base branch to a non-branch identifier. Then the GitHub Enterprise server released the fix on March 2nd. A researcher got a nice bounty out of it. They got a $25,000 bounty. But yeah, I mean, it was good that this was found by a researcher and not somebody who was looking to actually do damage, because
Yeah,
this
I guess
could have been a powerful attack.
one benefit here is that it's kind of easy to detect if it was used by looking at the pull request and looking at the base ref and just seeing if it references something. So there's at least kind of that benefit of detection to kind of look back and see, at least potentially, depending on how they deal with deleted stuff. I'm not sure how GitHub actually handles a deleted PR, but there is at least that hope, and I believe they do mention that they had looked for other cases of this somewhere in the report, trying to detect that sort of bad reference.
Yeah, they mentioned that they couldn't find any evidence of it being exploited in the wild, which is good.
Jimmy, it's one of those issues. It's simple to understand. You're basically just using an unexpected reference or like an unexpected type there. But actually, like, thinking to try it, obviously not a lot of people would have thought to try it, or this would have been discovered sooner. I do wonder, actually, I don't think anything said about, but how long the issues existed. I don't think anything stated, but I'd have to imagine it's been in there for a while.
Something like this, yeah, I agree. I don't see how this could have been recently introduced, because it's not like anything with pull requests has changed in the last couple of years. Yeah, I mean, and it's another like example of how sometimes companies or like a developer thinks they're secure because they secure one vector of exploiting an issue against, like, they do like heavy sanitization on it. But like the article calls out, like the fact that they have different levels of strength of mitigation when it comes to creating pull requests and updating them. I think that's just something that, like, it's so easy for people to think, okay, I've made it so when people create this thing, it's fine. It can't be abused in any way, but they don't consider, like, oh wow, wait, they can actually update this thing. They can delete this thing.
Well,
Like,
part of it isn't necessarily that they don't consider they can't update, but when you split the code like that, you're creating two places that need to be maintained. So every time something changes, now you've got to go ahead and maintain not only the creation, but the update or any other code that might update it also. That kind of comes down to where I like to hit on the point of centralization and kind of centralizing code. So it's like when you're creating, like if you have it pass through the same checks, you're reusing that same code instead of having it separated. And this sort of issue definitely indicates that they're separating that code. They're doing those validations in separate ways. Whereas just having something where they can like set it, validate, and then have that validation check run and then commit it would kind of allow them to centralize some of those validations. I mean, I'm not saying GitHub needs to change it, but I am saying like that's a better structure in general when you're able to kind of centralize those changes so you don't have to maintain it in every possible place. And I think we've got a issue later on in this episode that kind of has that same issue over just not being centralized. We've had plenty of issues related to that also. I don't know. I think centralization's a big deal that just gets overlooked a lot.
yeah, it gets kind of lost in the forest of the trees. Yeah, so I really like this issue because unlike some of the past ones we've covered when it comes to GitHub or GitLab or whatever, this one had a practical and a very impactful angle to it. It didn't rely on some like weird configuration or a self-hosted GitHub or GitLab instance or something like that. This was a real issue that affected GitHub.com and could have been exploited by anyone, even if you didn't have access to the repository, managerial access over the repository, because we have covered some Git issues before, but you needed to be like a maintainer or something, so it was kind of an insider attack where this could be hit by somebody from the outside.
Though in fairness, I think that insider attack was like you have to be a maintainer and you can get RC on the server. So like it still was a privilege escalation for sure.
Yeah, there were a few attacks around that. I think there was another one that also required maintainer access. It was just a kind of cell phone. But yeah, I mean, we've covered quite a few Git issues on the podcast, actually, thinking back on it. All right, so we'll move on to our next topic, which was how we found and fixed a rare race condition in our session handling. It was a little bit of a tongue twister, rare race condition. Z, I'll let you take this one away because you got a more thorough reading on it than I did.
Yeah, this issue actually kind of touches on a little bit more of the binary level. Not exactly, but because GitHub is written, it's a Ruby on Rails application. So you generally don't think about too many of these sorts of binary level issues, and this one isn't exactly binary level. You'll get what I mean in a moment. But what they ended up noticing is their web server itself. The core of the issue had to be that there's this environment variable that would just store kind of the environment of the request. Think like HTTP headers, cookies, things like that came in with the request. It would store that in this environment variable. And then between every request, it would simply clear that hash map, the environment variable being a hash map. It would clear that and then start working on the new request. It wouldn't recreate one. It would just keep reusing the old one. So what ended up happening here is they had a race condition. So the actual thing that was reported was basically a user was logged in on their own account, went to go access another page and found themselves logged in as another user. So like authentication as another user. So you can kind of imagine the security implications from suddenly having access to somebody else's account. They ended up like you weren't really able to control who you'd get access to, or at least you couldn't control it without controlling who made the next request. So the security implications aren't that great with it, but still an interesting bug. So jumping back to what I was saying about how it's reusing this environment. So it just would store a pointer to the environment and kind of keep reusing it. So what ended up happening is basically the vulnerability required 3 requests to kind of come in pretty close sequence. You'd have an unauthenticated request come in, and that would, register some callbacks for like error happens, whatever, and reading certain data out of it. Registers these callbacks, and often in background thread, some exception happens. They don't elaborate on that, just an exception happens in like this background processing. And, it maybe kicks off this callback that's trying to read the authentication info out of this authenticated user. At the same time, a second request comes in. This is an authenticated request. So because that unauthenticated request, it's already actually finished, but that environment variable is still pointing out to, or in those callbacks, it still knows about that environment, and it thinks it's pointing to the unauthenticated user, that first request, when it's in this callback. So it tries to read the auth info. Notices it doesn't have it, so it's kicking it off to the environment thing to be read, which is where it ends up reading it out of the second request that came in, which is now kind of the one that owns the environment, and it reads that user's environment info, which means it's reading that user's like session identifier and all of that, and it's going to sit back, and when a third request comes in, assuming that second request ended, third request kind of has ownership of that environment now. And now that original request to kind of read the auth info, that callback that was registered, ends up returning yet again. It says, okay, now we have auth info for this request. Let's write that out to their session, writing the second user or the second request authentication info to the third user's session. It's kind of a roundabout thing. They go into it quite a bit here and kind of lay it out better than I think I did, in terms of exactly what's kind of coming in and going on, but overall, the whole issue just kind of ties around that shared memory and the threading issue. And they laid out here in these 8 steps.
It's
Over.
always like fun to see. I think we've covered a few of them in the past, and I've kind of said the same thing. But it's fun to see issues you usually see at the binary level, like race conditions, happen at the higher level, because it's kind of rare that you see that, honestly. So yeah, it's always fun to see that. This does look like a pretty like complicated like attack in terms of following the control flow. Um,
Well, it's complicated in terms of how it happened. In terms of like they're
yeah,
explaining exactly what happened in the code caused this. When it comes to like what an attacker might say, like let's say you had some way to control all of these requests coming in. Like I could imagine an attack scenario being kind of related to like social engineering, and you're able to get this other person's request to come in at just the right time. And it is important to know, like all this also happened to be all of these requests had to come in and be processed by the same process. So that means load balancers and all of that, which is splitting, because GitHub is not just run by one server and one process. So you don't really have too much control over that to begin with. Maybe by the same region. Like there are some things you can do, but hitting the same process is going to be hard. But let's imagine you had that. You still kind of need to time a victim accessing your page just right. So I could imagine something like this. If you were going to try and attack it or attack using it, you'd have to use it with some other attack. Most likely thing that I could kind of imagine is like if you had a cross-site scripting somewhere, you have them visit your site, and then your site times these that second user request being theirs, and the request that you kind of want to get the session with to be right after it. By knowing that, okay, we just redirect them there, and then you hit it. Like I could imagine some sort of roundabout attack, but this does feel very hard to actually exploit.
that's a like cool attack that you laid out. I like that. But yeah, it seems the practical implication is
Yeah,
kind of
it doesn't
limited
seem
there.
like a very practical attack. It seems like it could be fun. It could be something like, in the movies or something. Got to time it just right, but, the movies don't get things that accurate, so.
Yeah. But what's funny about this like kind of issue is the fact that um, even if you don't understand all the intricate details, you could still trigger it. And like as a matter of fact, like this issue was triggered by accident, right? They ended up discovering it because it was reported by a user who was authenticated as another user by mistake. So it's kind of funny to see the issues come out of people reporting accidental bugs, but yeah, like practically attacking this does seem difficult.
Yeah, like if you're going for an untargeted thing, you might be able to kind of watch for it or even cause it, because two of the requests are, can be attacker controlled. That unauthenticated one is maybe I'd be interested in like the likelihood of success if you have that unauthenticated one, because as long as that request happens, it seems like the other two should follow depending on how things get threaded. So you should end up doing that. So like if you were going untargeted, just trying to get access to random accounts, you might be able to get something like that and just trying to cause a mayhem. You might just be able to make that first request and keep seeing when and just see what account you get access to, basically. So I guess that would be a more practical attack with this.
Just do like a slot machine on see who you compromise. Oh, look, this guy has some pretty cool repositories.
Or this
That'd be
guy has
fun.
no repos.
Yeah, probably more likely. So yeah, I mean, yeah, maybe there is a practical attack. It's just hard to target. Yeah. All right. So we'll move on to another Git paste issue.
Yeah, well, this one's GitLab, so we're done with GitHub.
Yeah, now we're on GitLab. So, yep, another returning guest. This was a HackerOne report that allowed an attacker to delete a user's account with no consent or authentication via GitLab's handling of GDPR. So, GDPR is pretty recent. A lot of people that are listening probably know what it is, but yeah, the European Union introduced the General Data Protection. I forget what the R stands for. But basically, it it forces companies to let users have control over their data and allow them to wipe their account data from a service if it operates in the European Union. So yeah, GitLab tries to respect that, and they allow people to delete their accounts. But the problem was, you can send spoofed emails from a victim's email to the GDPR request at GitLab.com email. And there were no security questions asked, and there was no like checks against spoofing. There was no like validation of the email. So when that happened, your account associated with that email would just get deleted within a few days' time. So yeah, I mean, not a super exciting issue. It was just like a lazy implementation of GDPR.
Well, it's also it's not really a technical issue. This is a human issue, or just the lack of technical implementation.
Yeah.
Email for the GDPR account removal. I mean, a lot of places will have that as something where you log into your account and you can click a button to delete your account with GDPR, or as part of and you can do the same thing for your right acts. Like the GDPR options are there as part of your account options, and not just send an email. Like, it feels like it's a little bit lazy, and then of course vulnerable to social engineering.
Yeah. So the proposed fix here was to add some level of manual verification, such as like date of birth or government issued ID. But it's kind of funny because, as mentioned in the impact section of this post, due to how badly they implemented this ability for users to exercise their GDPR rights, this actually violates GDPR in and of itself, because I think they mention, it breaches GDPR law Article 15, because it allows people or an attacker to delete user accounts without user interaction. So, they tried, but you don't always succeed. By trying to facilitate and abide by GDPR, because they did without verification, they still broke GDPR. But yeah, kind of a fun issue in that respect, but technically speaking, not super interesting.
And I will also just shout out that the same researcher here also has a research paper, which is actually looks like presentation slides, kind of looking for like abusing GDPR stuff for like account takeovers, for deleting accounts, and doing an overview over how other places also kind of handle this sort of issue.
Yeah, it's an interesting angle to take for sure. There's probably a lot more services out there that have similarly exploitable issues or social engineering holes. All right, so next up we have some Linux kernel bugs that have been in the kernel for a while, but were discovered and exploited recently, demonstrating why we absolutely need Rust in the kernel, tying it back. But pretty much all of these bugs were in SCSI, which is a little bit weird. It's the small computer system interface. It's not really used anymore.
Didn't I bring this up last time we talked about, but you could definitely say it as SCSI, and I really like saying SCSI.
You know what? As soon as you started talking, I thought about that. I was like, wait, we talked about this before, but I can't remember when, unfortunately. Like, I don't have an episode number. But okay, I'll try to convert. So yeah, pretty much all these bugs were in SCSI. 3 bugs are detailed in this article. The first one they detail is a heap overflow in the iSCSI host get param, where you can get an iSCSI string attributes, and you can make it span larger than one page. And the problem with that is when a string is processed when that string gets processed in an internal sprintf call, when you're doing something like reading the attributes on the sysfs file system or the secfs file system, it puts it in a buffer that's 1 page large. So if you have a string that can span more than 1 page, it'll overflow there, right? The string size is only limited by the maximum size of the netlink messages, which is far beyond the size of 1 page. It's either like over 4 billion or over 65,000. In most cases, a page size is going to be 4096 bytes or hex 1000 bytes. So yeah, that heap overflow, they actually ended up exploiting and chaining with the second bug, which was an info leak where a kernel pointer is disclosed to do transport handles being readable from unprivileged users on sysfs. It turns out the handles, as they call it, are actually kernel pointers, which is just that's some real big brain stuff right there. Instead of using like
Yeah, well,
descriptors or something,
it was
just use the
probably
pointers.
written. It was probably written before they really cared about exposing kernel pointers. It's just like, oh, there's a unique value. Like all of them are going to have a unique location where we're storing their transport structure. So, that'll be the handle. That'll be the unique handle for it too. Just, saving time in their code, I guess. Like I said, probably written before people cared about exposing that. Like, I mean, what were they saying? 15 years old for
Yeah,
some of the bugs. So that's
what I'll say
before.
around that though is that Linux has always been pretty good when it comes to keeping pointers internalized in the kernel. Windows, not so much. Windows had a lot of these types of info leaks where they just willy nilly pass off kernel pointers into user space. But like, I always thought Linux was pretty good for that, even back like 15, 20 years ago. So
I'm
I don't
not
know.
sure
This is
about that.
interesting.
Maybe, but I don't like before there was like ASLR or something. I don't think it was a huge concern.
Yeah, I suppose so. Because before KSLR, like you could pretty easily guess like heap addresses, and you could know for sure where .text addresses were. So yeah, I mean that's possible, but generally speaking, like Linux has been better with keeping the pointers internalized, and yeah, I mean kernel pointers are never something you want to leak to user space because it pretty much entirely defeats the point of kernel ASLR. Um, so yeah, the attacker chained those two bugs together for an exploit, which I'll get into in a few minutes. I will quickly touch on the final bug. There was a third bug included as well, which was an out of bounds read on the send PDU function, which is also reachable from netlink sockets. Multiple values that are passed in there are attacker controlled, and they just don't validate them, which includes some variables used for size calculations for the preceding header, which can allow you to read up to like 8,000 bytes or something at a controlled 32-bit offset. That issue also probably could be exploited as well, possibly on its own even. It'd be interesting to try to tackle that issue. But yeah, the author just ended up exploiting the first two with the sprintf based overflow and the info leak to write an exploit that would get arbitrary read write and code execution. How they did that, they go into detail on the the exploit strategy and what they did. They basically used the info leak to get the location of the kernel module's global region, which contains all the like globals related to that module. Then they used the heap overflow with the pages. They groomed the heap so that they can smash the next chunk's free pointer to point to iSCSI transport objects, and then smash the function pointers in that, which are used for writing buffers to user space usually. And they abuse that to get arbitrary read write, which is pretty
And
much the
there,
most powerful primitive you can have in the kernel.
the grooming that they did also wasn't too complex here. They sent several, message queue messages in there. Didn't receive them, so they'd all kind of end up getting allocated all together. Received several of them, so you end up with a free list that has several items that are all together in memory. And then when they triggered the overflow, it will allocate one of those in the free list, and they were able to smash the next object in the free list, smashing its kind of next pointer, as it was kind of a singly linked list. As often some of these free lists are within the kernel, they don't have a lot of excess checking in there. But it does cover some of that, which I always appreciate seeing in some of these write-ups. And I think actually when it came to the KSLR leak, when they were able to leak that one pointer, so that handle the transport structure, like that thing contains a bunch of function pointers already. So like that itself, like they didn't need to do much extra calculation off of it.
Yeah, it was a very
A very
centralized
powerful
structure.
leak.
Yeah. So yeah, love seeing kernel issues. The POC that was so there is POC code on GitHub. If I failed to mention that, it has support for the 4.18 kernels. It can work on other kernels as well. It just needs the offsets and stuff to be updated. I will be honest. Until this like write up, and I looked a little bit at the POC. I didn't know that some of this code was even reachable. I thought you would need like a special like hardware configuration or a kernel build to be able to access it. So, that was kind of interesting to see. It's always fun to see what attack surface you don't realize is exposed that is actually exposed. And yeah, like these issues are really old, so you could use this on older kernels too. Like a lot of IoT devices are running like 3 point something, I think, last I remember. So you could probably use this issue on some older like IoT devices and stuff like that if you were looking for a privesk.
I feel like we've talked about even some IoT that's still running on like a 2.x.
Yeah, it wouldn't surprise me at all. So yeah, I mean, just some fun exploits, pretty easy bugs, but they don't have to be super interesting bugs in order to compromise the kernel. And yeah, that's what they did there. So, all right, we have another fuzzing based topic from VoidSec, which talks about fuzzing an image viewer called FastStone, and one of the vulnerabilities they found and exploited. Mostly, though, it focuses on the fuzzing methodology and some info on file format fuzzing using Peach Fuzzer, which is a very old fuzzing framework, but it's useful for file format fuzzing and stuff like that. And this image viewer is apparently included as a bundled application on various system installations and has a lot of downloads, almost 14 million on CNET, which is interesting because I don't know about you, Z, but I've never even heard of this image viewer. But apparently it's pretty popular, so...
Well, it might be there, but I mean, if you're just using the default, you probably don't even know what you're using, so...
Yeah. So, anyway, they tunneled their focus on an obscure but easily understood file format, being the cur, which is used for cursors on Windows. Non-animated cursors, anyway. Now, they detail both of the approaches you can take with peach fuzzing, being like the dumb approach with just doing like bit flips and other random mutations, as well as the smart approach, which uses like structured data, like structured fuzzing. They actually provide some significant background info on the smart fuzzing path and how data modeling works in Peach, which I'll kind of glance over here, but it's probably a good thing to read if you're looking to learn more about fuzzing and file format fuzzing and are looking at using Peach in particular.
I mean,
But
Peach is kind of a nice entry point because at least I've always associated it with more of the dumb fuzzing. I used Peach many years ago. It's just like kind of an easier introduction, and it is still kind of some structured fuzzing in the sense of defining a file structure with your Peach with which they kind of go into here. Like, I appreciate a lot of the background that they've included here.
yeah, so it's not smart fuzzing in the sense of like coverage guidance or like some level of introspection, but it's got the structured data, so it's more smart with what it sends and the types of input samples it generates. But yeah, so they let the fuzzer run for like half a day or so. They ended up finding 104 unique crashes, which, while that seems like a lot, it's not super surprising, honestly, when you're dealing with fuzzing, like when you're fuzzing software like this, especially in obscure, likely untested file format that's not used often. They detail one of the vulns they discovered, which was pretty much a stack overflow when reading a bitmap into a stack buffer. It would read it into a fixed size buffer, and it tried to figure out how much it needed to read by reading the bitmap header's bit count field, but it didn't really do any checks on it or anything.
Calculating based off of that, it ended up doing a shift based off of the bit count field to determine how much to read, which kind of created some other issues, but it wasn't just directly using that value, is all I'm saying. It was you taint the size it would read through that value.
Yeah. So since this was a 32-bit application and there were no mitigations, it was a pretty straightforward like SEH chain overwrite. They used the cyclic pattern to find their overwrite location in the bitmap and exploited it. The vulnerability wasn't particularly interesting, but I think the main value in this post is in the background information they provide. Now, somebody asked about what they're using to show the file structure. I'm pretty sure they mentioned 010 editor in here. Yeah, that's what they're using. They're using 010 editor. By the way, I really recommend that hex editor because there's a lot of useful extensions it has. Like there's template files that other people have written that you can use, or you can write your own template files. It's a hex editor, and you can see like they've got the colors that show which fields belong, like which data belongs to which fields and stuff. It's honestly very useful if you're like reversing an unknown file format, or you just want to get like a quick raw value out of a header or something. And it's very cheap. From what I remember, it's like a one-time purchase, and it's like $100 or something, or it might not even be that much. Yeah, 010 editor, like highly recommend for anybody that wants to do any reverse engineering or something like that. But yeah, I mean, the background information here was useful. One thing that I think you said you found interesting, Z, was the touch on the triaging aspect.
Yeah, just the fact that they included a little bit about triaging their dump file, or their crash file, I should say. It didn't go too deep into it. It's not like I'd say, read this to learn about triaging, but the fact that it even gets mentioned, because it's one of those things that often is just kind of stepped over. Even if they're fuzzing, they just jump right into the RCA.
Yeah, it's a point that's often neglected, especially with like the fuzzing based papers that we cover, unless it's specifically tailored to the triaging aspect. It's one of those things where it's really important if you're actually doing fuzzing, but in the development of like a fuzzer, it's just like put off to the side. Like, oh, people are going to do this later, but yeah,
Well,
it's definitely worth thinking about and
it's really a
keeping in mind.
It's really a separate skill too. Like, it is something that you need to learn to kind of do, but there isn't a lot of resource on how to do it besides you just kind of do it and gain your own intuition.
Yeah, and somebody in chat updated me on the price information. The 010 editor is $50 for home use. So yeah, I mean it's really extremely affordable, and it's very useful. So yeah, once again, highly recommend it. Up next, we have a ZDI post talking about a deserialization attack against Microsoft SharePoint, which is a collaboration product that integrates with Office. It's based around the fact that SharePoint will take document uploads, serialize them, store them in the session state, then later on, by providing like an ID, you can retrieve that document from the session state and get it deserialized. Now, normally
So
that session state can't really be tampered with.
I do want to jump in quickly. The documents are basically like forms. They're not really documents that you upload. The upload aspect is like uploading attachments, uploading other things, and they just both happen to be stored inside of the session state. But it's like the documents aren't uploaded by the user at all. You can maybe control the names of like the form and elements in a form, because the document being, I believe, being like a form in SharePoint.
Oh, okay. That's a good correction. Sorry, I worded that badly. So yeah, good interjection. But yeah, like normally that session state can't be tampered with by the attacker. You can't really mess with it post serialization.
So I guess I'll jump in again here. This is actually something I took issue with in their writing. Oh,
Okay.
so session data, generally, like an attacker, it's unique to each user. Like your session data in general is being stored. Like you have some level of control over it. So I actually really found it annoying the way this was written. When it's like, of course you can't edit the session as a user. Like, yeah, you can't gain arbitrary control over it, but of course you have some level of control over what's in there. If you didn't, if it was just the same across everybody, there'd be no point in having a per user session in the first place. And so there's the one sentence there where it's just like, and of course you can't do this, when reading this, like they're about to tell you how they went and did exactly that thing. So I found it really annoying just the way this was written. Like, I don't know. I mean, that one phrase in particular really bugged me.
Honestly, it was confusing trying to read through this. There were like some contradictions where I was like, wait, okay, let me go and reread this. Like, I felt like I had to spend a lot more time trying to figure out what they were trying to say because it just wasn't really clear. So,
well, it was written, I kind of would describe it in kind of a flowery way. A lot of excess messaging in there, a lot of just statements that don't really add anything, but maybe sound nice. I don't know. I feel like this could have been described a lot in a a lot more concise. In fact, to kind of make an attempt at being a bit more concise is where talking about everything but what the actual vulnerability is. The issue itself, like we kind of mentioned that state, you have some level of control over it, but you shouldn't have control over this document. That is added in there by the application, and like it's going to deserialize it, so it trusts what it's deserializing. Or in theory, it should be trusting what's deserializing. But all of these things are just accessed by ID in like a hash map sort of situation. So other data that you can control shouldn't be passed into it, such as an upload. So you can upload a file, it'll store the blob inside of the session, given another ID. What they found, if you swap the IDs out, so you use the ID of a file upload instead of an actual document, it'll deserialize your file upload instead of the document. So giving you control over what's getting deserialized, leading into kind of your normal situation of a deserialization code execution situation.
Yeah, it was basically like combining a replay attack with the confusion in the deserialization mechanism.
I don't even know where, like, maybe I missed it. How does the replay really follow in here, though? You're like, you should just be able to reuse that. Oh, okay, yeah, I guess with the view state, there is that aspect, yeah.
So overall, I think it was a cool bug. The write-up was, as I said, like kind of confusing for me to go through, though. It would have been easier if I was familiar with SharePoint, but I've never even downloaded SharePoint, so I was kind of going off of what they said in their article. And like you said, when they had that contradiction, like when it came to the session state, I was like, I was a bit confused, and it even tripped me up when I was explaining it. So, yeah, I feel like you could probably skip like at least like half the article since it was kind of irrelevant. It talked a lot about crypto and how like message authentication is used and what the purpose of message authentication is. Sorry. And really the only important thing you needed from that was the fact that message auth doesn't protect you against replay attacks. That's basically all it was trying to say. So yeah, I think it went a little bit too much into detail on what's ultimately not relevant, but if you can skip through the cruft and kind of resolve some of the weird messages in there, the issue is pretty cool, I think. So yeah.
Yeah, it's actually
just could have
like
been written a bit better.
It's definitely an interesting issue. I just, had a little bit of a problem with how it was written, but as an issue, it's definitely interesting to see.
Yeah, and that's why we covered it. So last week we covered an Android kernel exploit from Mo. Sorry if I mispronounced that. But yeah, from GitHub Security Lab. In that post, he promised it was the first of a 3-part blog series, I believe, of an Android full chain, and this is the second part. It's a Chrome sandbox escape. So this is a use after free in the payment app service bridge for creating payment requests in JavaScript, which is used by other objects like internal authenticators. And this issue is almost exactly the same as an issue we covered back in episode 67, it's basically centered around render frame host. Each renderer's main frame will get its own render frame host object, and child iframes will get their own RFH object. I'm just going to abbreviate render frame host to RFH for like the future because it's a lot quicker to say. So yeah, that means you can basically control the lifetime of RFH objects by controlling the lifetime of the frame that hosts it. So if you can find any interface that caches the RFH separately, there's a potential for use after free where the interface can hold a dangling pointer if the iframe gets destroyed. In the case we covered in episode 67, it was the SMS service interface. In this case, it's the new payment request interface. So it's a very similar issue. You can issue an API request to keep the object alive by getting it to add a callback and then destroying the object before it returns. Then when the internal authenticator Android object is destructed, it'll access that dangling RFH and call a function or a virtual method on it. It'll call getRoutingID. So from a high level standpoint, reasonably easy to understand how this can be exploited. You have a UAF on an object that has a function pointer that gets called. So yeah, by just forcing that object to outlive the iframe, you can get code execution by reallocating your own data in for the object and replacing that virtual function pointer. He did go into detail on how to expand the race window to make it a bit more consistent to trigger, because you are racing between, getting that iframe or getting the RFH destroyed and getting the corruption in before it's actually used. Yeah, he did go into some detail on expanding the race window. Again, for the exploit strategy, it was used the same strategy as the issue we covered on episode 67. Smash the V table to point into the global offset table and abuse the fact that Zygote always maps. It doesn't it uses boot time ASLR for like the libraries. It doesn't do it on each new process launch for whatever reason. Now, while this info is pretty similar to what we've already covered, I do think like the diagrams and stuff that were done up for this article are a good visual aid, and I think that was something that was kind of missing from the issue we covered on 67. And there's definitely still background info to be taken away here, especially if you haven't read the topic that I mentioned from episode 67. I also love diagrams, so yeah, it was nice to see so many in the article. But overall, it was a cool sandbox escape. It does assume that you already have a compromised Chrome renderer, which is probably what the third part is going to be when it comes. I would assume probably this week based on how it's been releasing so far. So going from compromising the Chrome renderer or RCE, then escaping with this exploit, then abusing the kernel exploit we covered last week, there's your Android full chain, right? So we've gotten 2 parts. There is still the part to come. So, we'll be looking forward to that. But yeah, I mean, overall, sandbox escapes are a necessary part of chains nowadays when you're hitting mobile. So, and it's one of those things where it probably gets the least amount of coverage from what I've seen. You see a lot of stuff on like the kernel side, privilege escalating once you already have that access. And you see getting that access, you see coverage of RCEs in the browser, but you don't really see that middle step of going from, okay, how do I get from a heavily sandboxed and restricted browser to a less restricted context in order to pull off the LPE? Because most of the time, you're not going to be able to LPE directly from the sandbox context. That's a really powerful chain and a pretty rare bug because attack surface is intentionally narrowed down for that.
I mean, at that point, is it even a chain anymore?
Yeah. So
well, technically, I guess it is if you're going from just RC.
It's a chain of 2.
Yeah,
but
still, I mean, it's powerful, as you were saying. Yeah, I'm definitely looking forward to the next one, though. I do think sometimes we might miss out on seeing the sandbox one, kind of for the same reason that we don't tend to see as many write-ups about like ASLR defeats.
Yeah.
And just because like it's a necessary step, but it's not like the popular like I guess the sexy step of, getting remote code execution or getting root. Like it's neither of those things, so it just kind of falls into that middle ground that is somewhat less interesting, like still very important, but not as glamorized, I guess.
Yeah, and as time goes on, these types of sandbox escapes are going to become more and more important, right? We're starting to see, especially over the last couple of years, there's more and more of a push to do strong sandboxing, trying to move attack surface that was previously exposed to applications, and then moving that so that you have to go through like layers of IPC or whatever to reach that. So as time goes on, there's going to be more and more steps required in exploits, right? That's kind of held true for the last while, and it's going to hold true for the next while. So these types of sandbox escapes it's good to be able to get information on them because, like I said, the information is just so limited, and they are going to be more important going forward. All right, so we'll get into our last exploit before we get into some research. We have a vulnerability in Wireshark. Really simple. Basically, just the fact that Wireshark allows multiple URL schemes in its clickable links and attributes it parses out of packets. So while it can contain like HTTP links, which would open the browser and take you to a web page, it can also contain file links or whatever other scheme might be used by the host operating system. So that could launch a file and if an attacker can get a controlled file on the system, it could lead to like code execution, for example. The report is basically stating that Wireshark should be sanitizing to only allow clickable links for HTTP links.
Yeah, and
not allowing any of these other schemes.
but they did also demonstrate that you could do a malicious file URL to a remote location. So they could have it download and execute the jar file.
Oh, fair enough. Okay.
Their example there was using the .com, and then it will use webdev to access it. So not like an HTTP server, you run dev, which I think we'll still end up using a get there. I don't know. It's been a long time since I've looked at dev stuff. Either way, you can set it up to run with a remote file that will download. But this is also one of those cases of, not clicking suspicious links. Because, I mean, that's what this comes down to. You're clicking on a link that's going to pull this file. I think it's slightly unexpected that it'll execute it also. Just because it passes whatever you give and just tries to do the, like Windows or your operating system decide how to open it. But ultimately, it does come down to, don't click suspicious links.
Yeah, I mean, I think this is something you could argue that Wireshark should attempt to mitigate. But like ultimately, if you're doing packet captures and you see clickable links that an adversary could be putting in those packets, you probably shouldn't be clicking them if they look dubious. It's not like this is a chat client and the attacker can hit unwitting victims by creating fake links or like making a link that looks like it goes somewhere, but it actually goes to somewhere else due to like spoofing it. You can see the link directly in Wireshark of like where it's going to take you when you're doing the packet capture. So it is kind of a little bit on you if you click that link and you get popped or something. So while you could argue this is an issue, I think it's mostly just a nice to have protection. So
yeah, it makes sense to just not make things that aren't web links. Or maybe clicking, have it go to the clipboard if it's not an actual like web link. Like that just makes sense in my opinion.
Yeah, that's a fair like compromise. All right, so we'll move into our research section. Our first research topic is from Praetorian, and it covers some various attacks and common vulnerabilities on OAuth 2 authorization servers. And it also showcases a tool that they developed to automatically test for the vulns they cover called KOAuth. So, yeah, these are mostly issues that come to like how authorization servers implement checks and not adhering properly to the specification or being lazy in how they do adhere to the specification. The first issue they cover is failing to validate or at least properly validate redirect URIs that are provided to send the access token to. We've definitely seen failures to validate such things before on this podcast. Things like checking if a URL is present in a string instead of checking that it's actually the host, like the URL is set to the right host. And that could be abused by chaining it with things like open redirect or like an XSS or something to direct the user to get a token with a malicious redirect URI.
Well, not even with that. Like, so the redirect URI is used after you've clicked the like, okay, I allow this website to, or allow this application, I guess, technically. I allow this application. You've given it the approval. It uses that redirect URI as that's the next place it sends you off to. And it sends you there with the token or with the access token.
Yeah.
Sorry, no, access. No, it is. Yeah, sorry, I was getting confused over access token and the actual. What is it?
One of the other attacks, I think.
One of the other tokens.
The authorization code, maybe.
Yeah.
Yeah.
But yeah, so it sends the access token there. So when an attacker gets that and controls the URL that's redirecting to, they can then make all the requests to the API. So they don't have to do anything. Like you don't have to do like any spoofing, any phishing or something like that. Like you've got access because you've sent or because you've now got that access token to swap it with.
Yeah. So that's a pretty powerful attack. The next attack they detail is issues with consent screens, starting off with scope confusion. So usually when you go to grant access to something, it'll tell you what scopes you're granting the application. Like if you try to, like if something asks for to be able to connect with your Facebook account, it'll give you a dialogue like this will be able to view your account information and post on your timeline or whatever. But if those scopes are incorrect or they're desynced from what the permissions are actually given on that token, that can be taken advantage of by attackers to grant them access to something that users aren't aware of, right?
Yeah, they kind of point out that this desync can happen between, like, when you register an application, you'll sometimes be asked, like, what roles or what scopes are you actually going to be asking for? And then when you actually make the request, you also send those scopes with the request. So there can be that desync where it might give you all of the scopes that the application wants at the registration time when the application registered, and not what they're showing you. Or it might do the opposite. It might give you all of the scopes there, or it might show you only what's being registered, but give you everything in the URL, things like that. Just these things there. One thing that I would mention that isn't exactly mentioned here, though, is there's also kind of the case of scopes not certain permissions or scopes can kind of unlock more APIs than you might think. So I believe it was Android kind of early on, so back around like 2011, 2012, I want to say. The Android applications, you can enter some of the scopes, and when you made like one scope for like it's been so long since I've looked at this, but you'd be able to make like one scope to like read some contact information. Like, it would give you all of the contact scopes, even though you only requested, and it would only show when you're installing the application. Like, it wants to be able to read these things, but you could also like edit and delete some of them or something like that. Like, it would just give you all the entire subcategory of like contact access when you made it, or when you had approval for any scope under contacts. So that's another thing kind of in this area that I'd be looking for when it comes to scopes.
Yeah, pretty much any API that doesn't do strong checking of the scoping could open holes, basically.
Yeah, well, that one kind of more has to do with the categorization of the different scopes. Because basically, like, it would categorize all of the scopes into like XYZ category, and then it would let you display to the user kind of more specifically what you were going to do. But when you gave them that, like, its actual scope was just the very permissive one, I guess.
It was more coarse permissions than fine grained.
Yeah,
or it was more coarse than it suggested.
Yes, exactly.
Another issue they cover is clickjacking, fooling the user into giving consent using like malicious iframes, for example. But the most interesting attack they leave for last. It's a downgrade attack on the authentication method, or the proof key for code exchange, and downgrading that.
Yeah, and this is an extension. It's not part of the main OAuth, so not everywhere's going to even have Pixie.
Yeah. So according to the Pixie specification, requests must specify a code challenge method parameter, which is recommended to be set to SHA-256. But the specification also requires auth service to provide a plain verifier for clients that can't send a SHA-256 challenge response. So with a SHA-256 challenge, the user will send the code verifier in SHA-256 to send it to the auth server. Then the auth server will respond back with an authorization code. Then that code gets sent to the client, which then specifies the same code and code verifier to get authenticated and gets the access token. But if the server isn't properly enforcing the authorization method, and the stored code challenge doesn't match the SHA-256 of the provided code verifier, instead of rejecting it, some of them might, for example, just fall back on the plain method, which in that case, an attacker can use the hash itself to gain access, downgrading the authorization method to plain. So that was kind of an interesting attack section. It just comes down to that laziness aspect, not wanting to have separate code paths for the two different verification methods, and instead just having like, we'll just check if this works out, and then if it doesn't, we'll just fall back. Like,
Yeah,
I could see how easy that would be to implement in development and not understand the implications of.
Yeah, it's an interesting failure path to take. I'd be curious on places where that vulnerability has actually arisen. I mean, I'm sure they're writing about because they've seen it, so I'd be interested in seeing that, but I don't think I've really seen it. I guess I haven't done much testing against anything with Pixie, so yeah, maybe it's just my lack of experience on there, but I would be interested to see this one kind of in the wild.
Yeah. The final section they just touch on briefly is like cross-site request forgery or CSRF. Just mentioning that servers need to relay the state parameter and the result if clients provide it, which clients are suggested to provide it. And that's something I guess they've seen where servers just don't relay that for whatever reason. As mentioned earlier, they did also put their tool up on GitHub, which tries to automatically test for these issues, which they call KOAuth. So yeah, I mean that's something you could take a look at if you're doing like looking at this kind of thing for like your job or something. That's probably worth keeping on your bookmarks. But yeah, not too much more to say there. It's mainly just like an overview of the different types of issues that they've come across and could be common amongst other servers doing the same thing. So we'll get into our last topic, which is a favorite topic of ours: fuzzing, fast fuzzing specifically. It's also got a pun in the title, which I love to see. Unbelievable performance for coverage guided fuzzing with Honeybee. This is from Allison Hussein from UC Berkeley, and it's about coverage guided fuzzing, or smart fuzzing as it's typically called now. And they've released a smart coverage guided fuzzer called Honeybee, which leverages Intel processor trace or IPT technology, which is basically hardware based tracing, and it'll record control flow as the CPU executes instructions. Now, leveraging IPT for fuzzing isn't new necessarily. I've seen it brought up before, and it's never really taken off because, as they mentioned, the overhead is quite high at 8 to 15%. In most cases, software-based coverage instrumentation is actually better in terms of performance, which is like really messed up that a software-based instrumentation is better than a hardware-based one. But they observe that the high overhead is mostly on the analysis side, not the recording side. And when they did some profiling, they discovered it's due to the decoding of instructions during trace analysis. So, by tackling the performance problem of instruction decoding, you can vastly improve the speed and actually make it better than the software based instrumentation that's so common.
Yeah, and I'll mention here for kind of what the IPT does with its actual log of what's happened is it doesn't store like all of the IPs that it hits, like all of the instructions that it's come across. Instead, it'll store things like this TNT.8 part there will say, okay, it took a branch and then it didn't take a branch, didn't take a branch, and took the next branch. And then you have to go to that location and follow the control flow yourself to see took this branch, didn't take, took. And you kind of need to go through that yourself and process all of the instructions to find where that control flow is happening rather than just logging all of the basic blocks that are getting hit. So that's kind of where that performance overhead's coming in. You've got to do that manual instruction decoding every time in order to figure out what's going on.
Yeah. And the main problem and why it's so slow is because of the lack of caching. So there was an open source library developed for IPT decoding called libxdc, which does use caching, unlike like the standard libIPT that ships with Intel or from Intel. And that operates up to 40 times faster than Intel's reference. But it still had its own issues. Mainly, it had some expensive lookups when doing like hash table lookups, and there was a lot of cache evictions because it did dynamic caching at runtime, right? So it would encounter an instruction, decode it, cache it, and then if that instruction was used again, within a reasonable time frame, it would access that cache. But if the cache got evicted and that entry was lost, it would then have to decode it again. So you had a lot of like redundant decoding just because it couldn't be cached with the dynamic caching they were doing. So what Allison did was they generated an ahead of time cache called a Hive, fitting with the B theme, that holds all the data needed for decoding. And with that, there's no like hash table stuff needed. There's no locking needed. It could be accessed by multiple threads since it was just reading the cache. It wasn't writing to it. So yeah, that was like far more efficient. This ended up being 30 to 176 times faster than Intel's reference decoding, which is just incredible, really. And it goes to show how important caching is when it comes to performance for this kind of thing.
The thing is, I'd be kind of interested in how much data actually ended up, like in terms of memory usage or something like that, ended up being as an overhead. When they're doing the entire control flow, like all possible flows for the application, like that's gotta add up, especially if you're talking about trying to do analysis on any sort of large application. So they didn't really include anything about that. The other thing they
That's a fair
mentioned,
point. You are kind of shifting the overhead from CPU execution to memory imprint. Yeah. Sorry, go
yeah.
ahead.
Well, the other thing is that they talk about this other one, the libxcc,
Mhm.
and then they don't compare against it. All of these comparisons are against libipt, which they already established as slow. What I want to know is why am I going to use Honeybee over libxdc, over the extremely fast decoder? Which they mention how, okay, it has this overhead with the caching, but they don't have any examples of how it actually sped up over that. All of their examples are just against IPT. Which, I mean, I'm sure I
Yeah.
can go run it and like find that out myself, but they don't demonstrate how it's actually better than the current best option.
Yeah, you can kind of infer it, I guess, where they say libxcc can operate up to 40 times faster, and theirs can like at base can be 30 to 176 times faster. But they don't directly compare against it in the table. Their table only compares against source instrumentation and libipt. So yeah, that is really weird. I don't know why there wasn't an
Yeah,
additional
like
entry with libxcc. That would be useful.
especially because they included it there, like I just would kind of expect them to use it and demonstrate how much more effective it is, basically. Like, I
Yeah,
mean, you can infer it, you get this idea there of this very significant improvement. I don't know if the analysis or comparison seems a little bit lacking. That said, it's kind of fair. They're also trying to promote their own thing. Like, it's not like this is a white paper, or it's not like this is a like conference presentation or something. At like anything like that. It's just, here's this thing I did on my internship. So, like, I'm not going to judge it that harshly, but I am saying I would have liked to see that.
yeah, it is nice to see the numbers. Um, Now, there were some interesting issues they encountered when they intended to use this library with Linux's perf driver. They found it ran into a lot of issues when using Honeybee's configuration, like it would lock up the system, for example. So they ended up writing their own driver and rolled the Honeybee analysis library, the Honey driver, and HongFuzz together for this fuzzing stack. Um, for testing, they fuzzed a small HTML parser and compared performance across various coverage mechanisms. In the table there, you see like no coverage, the source instrumentation, HongFuzz with libipt, and HongFuzz with Honeybee. Unfortunately, like Z brought up, not with HongFuzz with libxdc though. And that could also be because it would have also required a similar thing where they had to write a custom driver or make modifications to the perf driver. So it might have just been something that would have taken a while to test, which is like would be fair if they wouldn't want to cover that. Um, Now, Honeybee ultimately ended up being around 155 times faster than HongFuzz with stock Intel process tracing, and about 1.75 times as fast as source instrumentation, which is a pretty impressive speed up. That said, I would have liked to have seen it benchmark against some other software as well. This seems to all be based off one program, which is like a small HTML parser, as they mentioned. So as Z was talking about with the memory imprint, I would like to see this used on heavier software to see how performance would look, because like this is the kind of thing where it is going to vary depending on what you're testing, what instructions it's using, how much, like what the control flow is like, how much indirection there is, stuff like that, right? Um, and I will always put out the caveat that while performance is definitely important when you're talking about fuzzing, it's not everything. There is like a major like focus on performance, but I feel like it does kind of take away from some of the other aspects sometimes. Um, that said, like I still think this post is really cool, and it's something that people should definitely take a look at. Anywhere you can remove bottlenecks is good, but yeah, I just wish this was like more than anything. I wish this was tested on more software. Which, to be fair, it's open source, so you can test it yourself on other software. It just would have been nice to have like a quick access to benchmarks on maybe like 3 or 4 programs or something. But it's not a white paper, as he mentioned too. So it's fair that that's not here. It's just like a personal wish, I guess.
Yeah, touching on the performance aspect, in this case, performance I think matters maybe a little bit more because when this is something that could be plugged into other fuzzers. They're plugging it into HongFuzz in this case, and HongFuzz is the one that's actually going to be doing the mutations and all of that other stuff. This is just giving that analysis, I believe. Maybe this also did the mutations. I don't believe so, though. I believe that's done by HongFuzz, and then it just gets the path information and passes that along. So even though those other areas are important, the overhead in the analysis is kind of crucial here. Like, performance matters when it's only doing the analysis.
Oh, for sure. Like I said, it is that removal of the bottleneck, right? Like, in this case, you are bottlenecking on that analysis and the tracing. So removing that bottleneck is awesome. And I don't want to take away from this post. It is just something I bring up because it's like we cover a lot of topics that try to tackle performance when it comes to fuzzing, but not so many when it comes to like trying to generate better test cases and trying to do other things that could help with finding issues but might not be necessarily performant. Yeah, it's just something that I have observed. But in this case, like you said, I think that focusing on performance is totally justified, and this is like a good step. I think people should definitely take a look at this. Like I said. But yeah, I mean, it'll be interesting to see. I think we will see some other people maybe try this out and benchmark it. So I'll keep a lookout for that, and I'll probably take a look at this myself too, because taking advantage of Intel PT is something that people have been looking to do for a while, and it's useful to leverage that where you can. That said, that'll wrap up that topic. We'll segue into our shout outs of the show before we wrap it up. Z, I'll let you get into your shout out because I don't have any again.
Yeah, I don't have much to say about this one. It's pulling bits from ROM Silicon Die images. I haven't actually finished reading it, but it does seem somewhat interesting. It's on the hardware side, so if you're not into the hardware stuff, fine. I've just been trying to get into it a little bit more, so I figured I'd share that. And the second shout out is just that we had the lovely suggestion of odayfans.com, so I've launched that. Basically just contains a feed of a lot of the... It's a filtered feed of the feeds that I tend to follow to find the topics for the podcast.
Yeah, right at the top there, you can see 2 of the topics we've covered in this episode. So, yeah, I mean, it's useful because some of these sites don't have their own feeds, right? So it's an aggregation of multiple sources where you might not be able to get it otherwise. So while it is a meme, it's also a useful meme. So that makes it infinitely better,
Yeah, so a lot of the feeds are just from normal RSS feeds, and I just apply a couple filters on it. I also have a program on our Day Zero GitHub that generates a few feeds, such as this will report on anything that's a high on HackerOne. That comes from the other code that I wrote to generate it, or not sure if there's another example. Oh yeah, Project Zero's bug tracker is another one that I'm generating my own feed for.
Yeah, so basically just a useful aggregation place. So we also have shirts on there for anybody that's interested and wants to get a 0 Day Fans hoodie or something. We did have some requests for those, so Z got a store up for that. So yeah, I mean, you can check that out if you want to.
Finally buy our swag and get a shirt with the with our Zero logo on it too.
Yeah, very fancy. But yeah, so that'll wrap up our podcast. Thank you to everyone who tuned in. You can catch the VODs on Twitch or on other platforms like YouTube and Spotify and other platforms that sit on our anchor 24 hours after the stream. Streams for PS4 exploitation will continue this week, but like it's been for the last week or two, no scheduled streams, just kind of whenever I have something interesting I want to show off and work through. Probably won't be as frequent as some of the like previous weeks too, but we'll see. Follow us on Twitter and check out our Discord for notifications of when those streams go up, and as well as when we do our podcasts and anything else that we put out there. We'll be back again next week though for the podcast at the usual time, 3 p.m. Eastern, 12 p.m. Pacific, and we will see you all then.